So we got a 10th term here of this geometric sequence. First of all, we're told it's geometric, so then you can take that shortcut. Because if you're told it's geometric, you know that you're going to be multiplying by the same thing each time. So what are we multiplying by? -3. And one way we could find the 10th term is just by keep multiplying by -3 as we go along. Okay? And for the 10th one, that would take a little bit of time, but it wouldn't be too bad. Okay? The other thing is we can use the same idea that we had when we did differences and say, well, if I look for a pattern, I start with term 1 is 2, right? The second term is just that first term, and I'd have to multiply by -3 once. If I started from my first term and I wanted to get to 18, how many times would I multiply by -3? Twice. So I'd start with my 2, and then I'd multiply by -3 twice. To show multiplying something 2 times, we can use an exponent. That would be multiplying twice. When we get to term 4, which was -54, we could say, well, if I started from my first term and kept on going, I'd have to multiply by -3 3 times. Now, using this pattern, what are we going to need to do when we get to the 10th term? Start with our first term, and how many times would we have to multiply by -3 before we got to our 10th one? 9 times. Now, if you go to your graphing calculator, if you're using exponents, so here I'm going to go 2 times bracket. Here's your negative sign, which is different than your subtracting sign, -3. And if I want to do an exponent, above your divide sign is this button. Some calculators, it'll move it up. Some calculators, it'll just draw the hat sign. And we find out our answer is -39,366. So if you're new with the graphing calculator, you should have it out so you can practice these things as we go. So you can see if you can get these answers and have it work out for you. The nice thing about the graphing calculator, as you can see in a more complicated question that I did earlier, you can type in a big formulas and see everything that's there and just push enter once and have the right answer. How did I put? The hat button. So if I want to do 5 to the power of 3, I hit that button right there. Okay? On your calculator, it probably actually draws a little hat button, right? And then you just put the 3, and then it should tell you 125. Is this one that converges or gets diverges? Does it get closer and closer to a number, or does it spread out and get farther and farther? So this one is divergent. And one of the things that we're going to go towards is looking at, here we got to T10. Okay? We're going to eventually want to make a formula for this. So if you kept going and stopped at any number n, how would you get there? What would the formula look like? Well, we would start with 2 again, right? Which is our T1. Then we're multiplying by -3, which is our R value. And how many times would you have to multiply by the -3? N minus 1 times. So on your formula sheet, if you're looking at it, you have that formula. And that's where it comes from. In fact, all of these formulas that we have, someone's doing the math, looking for a pattern the same way that you were looking for patterns in sequences to find out what goes next, recognizing the pattern and saying, how can I generalize what I see? I can generalize that I always have term 1 to begin with, that I'm always multiplying by my common ratio 1 less than whatever the term number is, and so that's how I can create a formula.